The LGM-35A Sentinel is the United States' next-generation intercontinental ballistic missile (ICBM), developed to replace the aging LGM-30G Minuteman III, which has been in service since the early 1970s. Sentinel is designed to maintain the land-based leg of the U.S. nuclear triad well into the second half of the 21st century. Its primary role is strategic nuclear deterrence, ensuring that the United States retains a credible, survivable, and responsive nuclear force capable of discouraging adversaries from launching a nuclear attack. The Sentinel program was originally known as GBSD, Ground-Based Strategic Deterrent, before being officially designated LGM-35A Sentinel. The renaming reflects a broader shift in philosophy. Instead of merely replacing an old missile, the program aims to modernize the entire ICBM enterprise. This includes missiles, launch facilities, command and control systems, communications networks, and ground infrastructure, creating a fully integrated and resilient deterrence system rather than a simple one-for-one missile swap. One of the main reasons for replacing Minuteman III is age-related limitation. While Minuteman III has been upgraded multiple times, its core design is over 50 years old. Components are increasingly difficult to maintain, spare parts are scarce, and continued life extension would become less reliable and more expensive over time. Sentinel is designed from the ground up with modern materials, electronics, and digital architecture to reduce maintenance complexity and increase long-term sustainability. The Sentinel missile itself is expected to be a three-stage, solid-fuel ICBM, similar in basic configuration to Minuteman III but significantly more advanced internally. Solid fuel provides long-term storage, rapid launch readiness, and high reliability. The missile is designed to remain on alert at all times, capable of launching within minutes if authorized by the U.S. National Command Authority, which is central to its deterrence mission. Accuracy is one of the most critical improvements in the Sentinel system. Advances in guidance technology, navigation systems, and onboard computing are expected to significantly enhance targeting precision compared to previous generations. Higher accuracy allows the missile to achieve deterrence objectives with fewer warheads while maintaining effectiveness, aligning with arms control principles and strategic stability goals. Sentinel is designed to be compatible with existing and future nuclear warheads, rather than introducing an entirely new nuclear payload. This approach reduces technical risk and cost while maintaining continuity with established warhead programs managed by the U.S. Department of Energy. The missile's payload section is engineered for flexibility, allowing adaptation as warhead technologies evolve over time. A key feature of Sentinel is its open and modular architecture. Unlike legacy systems that are difficult to modify, Sentinel is designed to allow upgrades to software, sensors, and components without redesigning the entire missile. This means the system can adapt to emerging threats, new defensive technologies, and future strategic requirements over its expected service life, which could extend beyond 2070. The missile will be deployed primarily in hardened underground silos across existing ICBM fields in states such as Montana, North Dakota, Wyoming, Colorado, and Nebraska. These silos are being modernized rather than abandoned, reinforcing the survivability of the force. Hardened silos complicate enemy attack planning by requiring an adversary to expend a large number of weapons to neutralize the ICBM force. Beyond the missile itself, Sentinel includes a comprehensive upgrade to launch control centers and supporting infrastructure. New digital command and control systems are being designed to replace aging analog equipment, improving reliability, cybersecurity, and resistance to electronic warfare or cyber intrusion. These systems ensure secure communication between national leadership and missile crews under all conditions. Cybersecurity is a major design priority for Sentinel. Unlike Cold War-era systems that relied on isolation and analog technology, modern systems must actively defend against cyber threats. Sentinel incorporates advanced cyber protection measures, encryption, and system redundancy to ensure the integrity of launch commands and prevent unauthorized access or interference. Another important aspect of Sentinel is improved reliability and testability. Modern diagnostics allow operators to monitor missile health more accurately, reducing false alarms and unnecessary maintenance. This increases confidence in the system's readiness while reducing the burden on personnel and lowering long-term operational costs. The Sentinel program also emphasizes human factors and crew safety. Launch control officers and maintenance personnel will operate in upgraded facilities with improved working conditions, modern interfaces, and enhanced safety systems. These improvements are intended to reduce human error, increase morale, and ensure consistent performance during high-stress situations. From a strategic standpoint, Sentinel strengthens deterrence by maintaining a visible and distributed nuclear force. Land-based ICBMs force any potential adversary to consider the impossibility of eliminating U.S. nuclear capabilities in a first strike. This uncertainty is a cornerstone of deterrence, as it guarantees retaliation and discourages nuclear aggression. Sentinel also plays a role in arms control and strategic stability. While it modernizes U.S. capabilities, it does not fundamentally change the nature of nuclear deterrence or introduce destabilizing features such as rapid maneuvering or unpredictable basing. This allows the United States to maintain compliance with existing treaties while ensuring its deterrent remains credible. The program represents one of the most complex and expensive defense modernization efforts undertaken by the U.S. Air Force. However, proponents argue that spreading costs over several decades and reducing maintenance inefficiencies will make Sentinel more cost-effective than continuously extending Minuteman III beyond its intended lifespan. Industrial and technological benefits are also part of the Sentinel program. Development and production support high-skilled jobs, sustain the solid rocket motor industrial base, and preserve critical engineering expertise needed for strategic systems. This ensures the United States retains the ability to design and maintain advanced missile technology domestically. Operationally, Sentinel is expected to integrate seamlessly with the other two legs of the U.S. nuclear triad: submarine-launched ballistic missiles (SLBMs) and strategic bombers. Each leg has unique strengths, and Sentinel provides prompt response and geographic dispersion that complement the stealth and survivability of submarines and the flexibility of bombers. The missile's design also considers future threat environments, including advanced missile defenses, space-based sensors, and precision strike capabilities. Sentinel incorporates measures intended to preserve effectiveness against evolving defensive systems, ensuring it remains a credible deterrent even as global military technology advances. The Sentinel program places strong emphasis on sustainability and lifecycle management. From the earliest design stages, engineers focused on reducing the long-term logistical burden by using standardized components and digital documentation. This approach makes repairs, replacements, and upgrades more efficient over decades of service, ensuring the system remains viable without repeated large-scale redesigns. Another significant improvement is in missile propulsion technology. While still using solid rocket motors, Sentinel benefits from advances in materials science, propellant chemistry, and manufacturing precision. These improvements increase reliability, reduce variability between missiles, and enhance overall performance consistency, which is critical for strategic planning and deterrence credibility. Sentinel also benefits from improved launch readiness and response reliability. Modernized electronics and environmental controls ensure the missile can remain on alert for extended periods with fewer interruptions. This constant readiness reinforces deterrence by ensuring adversaries know the system is always capable of immediate response if required. The program includes extensive testing and validation processes. Ground tests, flight tests, and subsystem evaluations are designed to confirm performance under extreme conditions such as temperature variations, electromagnetic interference, and mechanical stress. These rigorous testing standards reduce the likelihood of failure during real-world operations. Training systems for missile crews are also being modernized alongside Sentinel. Advanced simulation and training environments allow personnel to practice a wide range of scenarios, from routine operations to high-stress emergency conditions. These tools improve decision-making, procedural accuracy, and confidence without relying on live systems. Sentinel is designed with strategic predictability in mind. While technologically advanced, it avoids destabilizing features that could increase the risk of miscalculation by other nuclear-armed states. This balance supports deterrence while reducing incentives for arms races or preemptive strategies. Environmental considerations are also part of the modernization effort. New construction and refurbishment of missile facilities aim to reduce environmental impact through improved energy efficiency, safer handling of hazardous materials, and better land management practices around missile fields. The missile's long service life allows policymakers flexibility in future strategic decisions. Sentinel provides a stable foundation from which the United States can adapt to changing geopolitical conditions, arms control agreements, or shifts in defense priorities without facing immediate capability gaps. Internationally, the deployment of Sentinel sends a clear signal of commitment to deterrence and alliance security. U.S. allies rely on extended deterrence guarantees, and a modern, credible ICBM force reassures partners while reinforcing global strategic balance. Overall, the LGM-35A Sentinel represents continuity and modernization rather than escalation. By combining proven deterrence principles with modern technology, it ensures the land-based leg of the U.S. nuclear triad remains effective, secure, and credible for future generations without fundamentally altering the strategic balance of nuclear power.